So we're still talking about linear models. We're still in 3.5. This is kind of the third part to that. What test makers and people in real life expect you to know how to do is to take a linear equation and match it to a real-world situation. So this is going to come in 3 parts with this activity. And you're going to use page 1 for the next 3 times. And you can print that off so that you can be looking at it. But basically what you're doing, on page 1, you have some graphs. And you're going to analyze those graphs, and you're going to match them to the slope and the y-intercept on page 2. And this shouldn't be very challenging. We've already done this. So, for example, if I have this graph, and let's look at the red line. Clearly the y-intercept is right here at 0, 3, so b would be 3. And the slope, remember you get an exact point on the line, and you go from left to right. So it's up 4 and over 5, and it's positive. So the slope is 4 over 5. So that part of this first part of this assignment should not be very challenging. Then we're going to get to the second part of it, and that's the next assignment where you're going to match the same graph pictures to the equation. So for instance, this graph, the equation would be y equals 4 over 5x plus 3. Now remember, if a line crosses the x-axis, for example this purple line, its equation will be x equals, because that's the axis it crosses, and it will be x equals 3 because that's where it crosses. And if a line were to cross the y-axis, for instance this blue line, since it crosses the y-axis, it is a y equation, so the name of this line would be y equals -3 because it crosses at -3. So that shouldn't be too difficult, step 2 of this, to match a picture to an equation. Then we come to the third part of this activity where you're going to match page 1 to words on page 4. So what you need to remember is a slope is a rate. Always remember slope is rate. So a familiar example would be your income. Your income is usually paid dollars per hour. So assume I make $15 per hour. That can be written as a rate, 15 to 1, and we usually don't write it that way. We say that. So if I were to make a linear graph of that, it would have a slope of 15 over 1, because that's the rate at which I get paid. Well, if my employer gave me a sign-on bonus, let's say they give me a bonus of $200 for coming to work for them. Let's go lower than that. Let's go $20. A $20 sign-on bonus. That would be my y-intercept, because at time 0, I've already made $20. That's something that happens before any time elapses. So it could be a setup fee for a printer. It could be a monthly base fee for a plan or a subscription. a sign-on bonus. It might be the service call fee if you called someone to your house. If they charge you a certain amount just for showing up, that's what your y-intercept is. Now, if you don't have any of these expenses, for instance, you have a normal job and you don't have a sign-on bonus, that means if you work 0 hours on day one, or before you even started, they're not owing you money. And so you start from 0. And that means the y-intercept is 0. Or it crosses at the origin. So let's go back to our situation we're looking at here. Because we're talking about income. So we're looking at our dollars earned per hours worked. Now, you can't work a negative amount of time, so nothing over here is ever going to be on a graph for this particular situation. And probably you're never going to pay your employer, so nothing there will show up because that would be a negative dollar. So typically, in situations like this, we will only see what occurs in quadrant 1. And this is where you get those familiar labels. So this is time in hours. And the y-axis is money earned in dollars. And so you can plot some points. We were working for $15 per hour. So our slope was 15 over 1. So if we just went up 15, let's say 5, 10, 15, and over 1, we could draw a line for this. And you could look at this and predict how much money you're going to earn. Or really what people would do is, how many hours do I need to work? That is where linear models come in handy. So if we went to, let's do this on our enlarged quadrant 1 only. Let's say each line is 5. So 5, 10, 15. 15, 1 is our first point. And we know we started with nothing, with no time worked. And we know if we work 2 hours, we earn $30. So what you can do is graph that and come up with the equation to model or to demonstrate your wages. So the equation for this model is going to be y equals, we just said our slope or our rate was 15, x, and they're not giving me a sign-on bonus, so there's no y-intercept, and we typically don't write that. So the equation for that would be y equals 15x. Slope 15, y-intercept 0, and this is for a situation that might read, I earn $15 per hour. The important thing is the y-intercept is the money that you're charged or you earn initially. It's initial deposits, initial fees, anything like that. So for instance, if you have a plumber or an electrician come out, and let's say an electrician charges a service call fee of $50, and then he bills $100 an hour. So the rate is always the per. So if the rate is $100 per hour, the slope is 100. Well, because before he does any work, you already owe him $50, your y-intercept is 50. So the linear model to represent this situation is y equals 100x plus 50. And you can plug in some random values there, and let's say we need him for 5 hours. Well, if you plugged in 5 for time, you could say y equals 100 times 5 plus 50, and so y would be $550, and that's how much you would have to pay the electrician. Now he could use this also the other way, and he could say, I need to earn $50,000 this year. So $50,000 equals 100x plus 50, and he could solve for x. So 49,950 would be 100x. Divide both sides by 100. And so when you do that division, I cannot do that in my head. 49,950 divided by 100, that's 499.5 hours that he needs to work. Well, there's 52 weeks in a year. So if you divide that by 52, that means he only needs to work about 9.6 hours a week. And that's if it's a different service call, because remember this 50, he would have to have one client all the time. It couldn't be the same client over and over because it might decrease his yearly wage, and he may have to work extra time to make up for that. But since he makes $100 an hour, he'd only have to work an extra hour if it was not a new customer. Okay, so check your luck on these situations. And another thing to always remember are your variables. So you have an independent variable and you have a dependent variable. So the independent variable is always on the x-axis. And it's most of the time your time variable. So if faced with a situation that has time involved, and that could be hours, months, years, days, seconds, weeks, anything that involves time, if you're unsure, it's a pretty safe bet that that's going to be on your x-axis. Your dependent variable is anything else, and that's on your y-axis. So let's look at another example. Let's say I'm talking about the distance run. So if I have a runner running 5 miles per hour, and I need to write an equation to represent this real situation. Well, the independent variable and the dependent variable can be easy to find if you can make a sentence. So the what, or the blank, depends on something. And in this one, it will be the distance he runs depends on how long he runs. Okay, well, if you depend on something, that makes you dependent. So the distance is your dependent, and your how long he runs, or your time, or in this case your hours, is your independent variable. And now you know what axis to put them on. Now if you're not given time, for instance, let's say the water bill at your house, well, what does it depend on? So the amount of the bill depends on how much water you use. So if you depend on something, you are dependent. The amount of the bill depends on something else. So that is your dependent, or your y. And the other variable, the how much water used, is your independent or your x. Now, one final way to look at this is whatever happens first is independent. So in this situation, what happens first? Do you get a bill and then you can only use that much water? Or do you use the water and then you get the bill? Well, you use the water and at the end of the month you get a bill. So this happens first. Whatever happens first is independent and goes on the x. Okay, so this should help you with all three of those, matching 1 and 2, matching 1 and 3, and matching 1 and 4. So if you want to Google something on this, you're looking at probably a 9th to an 11th grade level, and you're looking for independent and dependent variables and identifying them. And you could also be looking at graphing linear situations if you wanted to strengthen your knowledge of these. Okay, good luck.